Hello, I will be discussing pre-order traversal iteratively in LeetCode. It's problem 144. You can do it very easily like this in uh, recursive manner, but I want to do it iteratively, and I want you to think of, we have to use a stack, but there is a trick to this. You have to realize something about return pointers, okay? I'm going to show you, I'm going to walk you through my thought process, okay? Before we get into that, let's just simply do a pre-order right now. So this is one, so this is self, left, right. So I printed self, now I go to left. And then I printed, now I'm calling the function on this, okay? Now it's gonna print self and then left, right. So it's gonna call its left. So that's self for left is null, right is null, we don't do anything. So we come back to the previous level. So 2 had done self, it had done left. Now it's going to do right. Right is 5. Now 5 is going to do self, left, right. So self, after that left is 6. 6 is going to do self. Left, right is null, so there's nothing. And now after that, 5 has done self and left so far. 5 will do right, okay? And the right of 5 is 7. 7 will do print self and then call left, right. There's nothing on left, nothing on right. Now 7 return. The function returns from here. Now this is done, this is done, this is done, that is done, that is done. 1 was done at the very beginning. Now the whole left subtree is done after 1. So again, I come back. Self, left, right. Now 3. We make a call on 3. 3 prints itself, and then 3 doesn't. 3 looks for its left. Left is null. That's why it calls its right subtree, which is right subtree, and 8. 8 prints self. It looks at and then it calls a 9. 9 prints self. 9 looks for left and right. There is nothing. The function returns from there. And then I had only done 8 left. Now I do call on the null. I get nothing, and this is the final answer for this tree, okay? Now, I don't think it was a good idea to draw through this because I wanted to reuse this. But anyways, I can just draw it again. I'm gonna pause the video for a second. There. Um, now I want you to think about how this function works on the stack, on the call stack, okay? So on every, whenever you call a function, you put it on the call stack. Let's imagine the call stack. And also you have to think about the return value. So the function starts executing over here. I'm going to call it P for briefness, preorder on 1. Okay, that's the first value on our tree. And then that runs this line fine. And then there is another function call. Now, 1 puts, before calling this function call, 1 this is a return pointer, okay? Return pointer. Now this return pointer tells you where to come back after this call has finished. Before you go, you will always set up a return pointer. So return pointer on, this is pseudocode. I don't think I should, I'm just gonna name it. This is line number 1. This is line number 2. This is line number 3. Again, in real code, there will be more lines, but this should suffice. And the return pointer is, we come back after line 2, okay? Now we call a preorder on the left child, which is 2. Now, again, the function starts here, and then you print 2. So I had printed 1, now I've just printed 2. But now I have to call the function on the left child of 2 again, right? So I put a return pointer over there. Again, that's we come back after line 2, and then I'm calling on 4. Okay. At 4, I print itself. Okay, so again, I have run this line, And now I'm going to call the function on the left child of the 4, which is null. So I'm going to call p on null. This does nothing, so I return from there. Now, now I am not working with any function at this time. So I'm going to pop this off. Oh, and there was a return pointer after too, right? So after this, so I have returned here for 4. Now I will call the preorder on the right child of 4, which is another null. Okay, there's another null right there. So I'm gonna call on that. And I'm gonna actually pop, no, not yet. So I'm gonna call on null, and then this is finished. Excuse me, I removed my stack by mistake. So this is finished. Now this function finishes and the function pops off, and we continue with the right child of 2, which is 5, and so on and so forth. Now this is the call stack, okay? Now the call stack can hold a bunch of information, including the return pointer. Now the regular data structure stack, the stack only holds one type of data, at least in Java and other languages like that. So unless you want to go the complicated way of storing a return pointer type value, there is an there is a clever way of doing this. I'm not going to say it's easy, but clever. Now, you have to think about breaking this function down. Notice that this is one part of the function, and after the return pointer is a continuation of the function. What if we execute all of this first, and then put the function on the stack, so whenever we return from the stack, we call the right child. Okay, so for this, we will need a stack and a pointer. Okay, the stack is called I'll be back. Means I still have not called my right child here. I'm right here. I called myself. I printed myself. I printed the called on the left child. Now I have, yeah, okay, I'm still recording. Now I have to call the right child. So, excuse me. Let's continue. So let's do this. So, and there will be a tree node pointer called current. Yeah, we can call it current call. Okay. This is so the current call means this is an actual function call, but we're not putting function call on the stack because this stack to be on the stack means this is the return. This is kind of, you can think of it as a return stack. So this is not the stack of function calls. This is a stack of functions that I need to return to. Okay, that's the very different import. That's the very core of this idea. So stack of functions to return to. Okay, this is not a call. The call is right here. So we'll begin by putting 1 on the call because that's the root. Okay, now the way we process this call is we first print the call. So we print the call, then we put the call on the stack and call on its left child. So how do we call? We put that over here. This is a call again. Okay, so we printed the 1. Excuse me. We printed the 1. Now we are calling on 2. Okay. We are calling on 2. This is our current call. Okay. And what do we do when we're calling something? We print that. We put it on the stack, and then we call its left child. What's your left child? 2, 4. Okay. Notice the 4 here. So we are now calling 4. Okay. What does it mean to call in this function? To call means to print, to put it on the stack and get the left child. Left child of 4 is null. Now, since this is null, then now I know that I'm not making any calls. I have basically, let me write that down, fallen off the tree on the right. Fallen off of left subtree, okay? Because where I am right now, this is a null, it's a void, it's the abyss. There's nothing there. I have to come back. How do I come back from there? I grab that and put it over there on our current. So we are gonna, this is not a current call. Okay, so I'm gonna make a distinction. We're gonna grab that and we're gonna continue with this, okay? Uh, so the way, just a moment. Okay, I named a variable. So you can use this same one, but that's confusing. So I'm gonna call it resume. Okay. So this pointer will grab something from there when you hit a null, because you fell off a left subtree. It will grab the 4 from over there and put it here. Okay. So I fell off a tree. It hurts. So let me call the right children for the ones in the stack, right? So again, to be on the stack means you have executed everything except this one. So we are going to make a call to the right child of whatever we just popped, okay? So we are going to have to make a call, right? So what does it mean to make a call? It means to put the right child into this variable. Now, in this case, the right child happens to be null because look over here, that's nothing there, so that's a null. We do the same business. Okay. Now, when this is null, we know so this is not only the left subtree, we can also fall off of there is no right child. Okay. So we can fall off either side. But whatever side we fall off of, we do the same thing. We still have something on the stack. We grab it and put it on resume. Okay. We are going to resume execution for this. Where exactly do we resume execution? Just before we call the right child. Okay, so we have to make a call on the right child of 2 and we'll be done with 2. We have nothing else to do with 2. We just need to make a call to the right child of 2. So who is the right child of 2? 5. So let's make a call to 5. How do we make a call? We put it on this variable. Okay, and that's nothing that's no longer needed. Okay, the resume variable. Now we are making a call on 5. What does it mean to make a call on 5? Oh, by the way. Yeah, so we are correct. So it means to print itself, and then to put itself on the stack, to uh, go to its uh, and to make a call to its left child. So I'm making a call to the left child of 5, which is 6. 6 goes here. Now, again, remember why that is, because every time we make a call, we print, we make a call to the left child, and then wait. Wait, where do we wait? We wait on the stack. That's exactly what we just did with 5. I'm just going to replay it. So 5 was on the current call. We Okay, there 5. We printed the 5 right there. Now we're gonna take it. We're gonna put it on the stack, and then we are gonna make a call on the left child of 5. So there is a left child 6. So again, we're making a call. What does it mean to make a call? To make a call means to print that. So here is 6. Put this thing on the stack. You go to the stack, and then call on the left child. I fall off actually. This is null. So I have null. Do I have any stuff on the stack? Yes. So when that's null, we hit this and we resume execution for. What do we resume execution for? The same thing. Let's put it back. Resume execution for 6. Okay. What does it mean to resume execution? Resume execution means we resume here. What does it do? We make a call to the right child. So who is the right child of 6? Right child of 6 is another null. Is the right child of 6 null? Okay, what do we do when we fall off a tree? We hurt ourselves, but then we take this over there. Sorry, I did not copy it over fully. We grab a value from the stack. I don't need that. We grab a value from the stack, and then we make a call to the right child of whatever we are resuming execution on. What's the right child of 5? So the right child of 5 is 7. So let's make a call to 7, okay? Now we are calling 7. What does it mean to call 7? we print it. Then what do? We uh, we pause its own execution, and before we go, we make a call to the left child of that 7. Left child of 7 is null, so we fell off the tree again. What do we do when we fall off a tree? We grab the 7 and we resume execution on that. We left the 7th sword over there. Doesn't matter. Okay, we're resuming 7. What does it mean to resume 7? We are calling the right child of 7. Right child of 7 is null. We fell off a tree. What happens when we fall off a tree? We grab anything left over and we resume execution. Now we are calling the right child of 1. Who's the right child of 1? 3. Okay, so we are making a call on the 3. So here is 3, we are making a call. How do we make a call? We print it, and then we put it on the stack, and then we make a call to the left child of 3. What's the left child of 3? Null. When we have null, we fell off the tree. What do? We can resume execution for 3. There is 3, and then what does it mean to resume execution? It means to call the right child. So let's call the right child of 3. How do we call the right child of 3? We simply put it over here. What's the right child of 3, by the way? It's 8. Okay, we are making a call on 8. Okay, what does it mean to call on 8? We print itself. We put it on the stack saying, we'll come back to you, call your right child, but let me call your left child first. What's the left child of 8? 9. As you can see here, left child of 8 is 9. We are making a call to 9. Okay, so what does it mean to make a call? It means to print yourself, put yourself on the stack, saying, okay, I'll be back, and making a call to the left child of 9. That happens to be null because there is nothing over here. Now we make a call to the left, and now we fell off a tree again. Whoops. What do we do when we fall off a tree? We continue execution for stuff on the stack. We still have 9 on the stack. Now we have to make a call to the right child of 9. What's the right child of 9? That's another null. Whoops, we fell off a tree. So what happens when we fall off a tree? We resume execution for something on the stack. We are calling 8. What is the right child of 8? That's a null. Okay, we fell off a stack again. So we fell off a tree. Now look, current is null, stack is empty. That means we are done. We are actually done. We printed everything. This is my step-by-step. I know it took a while for that to happen, but I think it's necessary to go through this to know what it means, okay? Now I'll show you my code and hopefully it will make sense. I'm not gonna write it out because I make a lot of mistakes, but I am gonna explain it to you. Whoops. Okay. So this is the function. I'm just going to walk you through this. So this is a res is a linked list of integers. It's a list of integers, the list interface. I have a stack. The stack is literally called I'll be back. Why? Because it means I have printed myself. I have called my left child. I'll be back and call my right child whenever I'm back. Okay, that's the idea. Now, this doesn't make sense to me. If there is no root, you don't do anything. Just return. There's no thinking here. Okay. Now, here is the variable I'm calling current call. If something is assigned here, it means we are calling it. Okay, that's our interpretation. And the stack means I have to call its right child. That's the interpretation. That's the idea. Okay. So remember, we've ended our function when we are not calling anything and we don't have anything to return to. Okay. Current call null means we fell off a tree. We're not calling anything, and then the I'll be back stack being empty means there's nothing to continue execution on. There is not, so we're done. The inner while loop, so what this does is it will uh, do the first part of the program, okay? It will print itself, it will call the child, and it will go back and wait on the stack. Let's see how we do that. So this is the printing phase. So we are adding the current call dot value to the result list, and then before I lose the pointer, I'm gonna push that pointer on the stack. So, okay, I still need to call your right child. Now I'm going to call your left child. What does it mean to call your left child? It means to assign the left child to the current. Now, the left child may or may not be an actual node, okay? If it's an actual node, we have not fallen off a tree. If we have not fallen off a tree, we are going to continue executing whatever left child we have. And for every child, we are going to push after printing, we are going to push it on the stack and reassure it, okay, go and wait on the stack. I'm going to call on your right child when I'm done with when I fall off a tree. So at some point, the current pointer will fall off the tree. It could be the left or the right subtree, but whatever. When that happens, we have a, what is this? I did not declare it. Yeah, this is tree, just a moment. I got a little confused there for a second. For some reason, I did not declare the resume properly. Anyways, let's continue on the code. So this is a pointer that pops off from the uh, I'll be back stack. It means, okay, I fell off a tree. I am ready to resume execution for any stuff that remains. Now, what does it mean to resume execution? It means to call the right subtree. So we assign the resume, whatever we got for resume, dot right to the current call. And right now, the right could be null. There could be nothing on the right. In that case, we fall off a tree again. If there is a right child, we come back and start calling its own left child. If there is no right child, we pop another node, and so on and so forth. So that is actually the end of my explanation. I'm gonna submit and show you that it runs. Um, it performs the same as the recursive solution. Uh, it does well, but this is a very thorough understanding of how preorder traversal works and how this call stack works and how we take the shortcut and do this instead of the return pointer. Thank you for your time. I know this is a very long video, but I could not make it any shorter, unfortunately. If you have any questions, please let me know, and I hope this helped you. Take care now.